Who here has coded in Rust, by the way? Is a useful question to know, by the way. Just so this is the program, and I know it's horrible to view right now, but we will break it down, and we're going to be doing something really, really cool. We're creating a command line application that enables us to actually view inside a file to kind of create a picture of what it looks like. And so you'll be able to, if you've ever done anything with binary content, or you've ever wondered, like, what's the difference between a binary file and a text file? Or like, what does a file format look like inside? We can actually create a picture of that. And so I'll just toggle this off. Oh, that's the wrong button. Oh, that's not what I wanted either. The horrible thing about when you're talking and editing is that life becomes very complicated when you try to do about 6 things at once. So it's great to see everyone in the audience. I'm super excited. Oh, many publications is now streaming. Oh, right, that's the auto. No, that's not a comment, that's a bot. And where are we? We're in the right directory. We are. So this is actually an Easter egg inside the book. I don't know if you've already bought it or not, but if you so this is an Easter egg inside the book. If you download the source code, this is an extra example that doesn't actually exist in the text. But it's used in the text. So to provide an example output, I've got an EPUB file that looks just like this. It's just a scrambled array of bytes, and there's almost no structure in here at all. Whereas if we go to an HTML file, you'll see that inside it, there's a huge amount of repetition. There's a lot of white space that's been created, also a lot of this kind of blocky dark color, and very few black segments. And all of those have become significant over as we get going. And just to kind of like flesh it out a bit, here's what the text version of that file looks like. So there's very little white, but there's a lot of gray. And we will, I say we, if you choose to follow along, we will explore why that is, and like allow you to create your own files. So to start off, I just want to go with the workflow of creating a project in Rust. So if you've used Python or what have you, all you need to do is like Python space file name, and then you go. Inside this thing, inside Rust, it's a compiled language, which means that we actually need to create a we need to compile our source code. I need to fix this problem. So the first thing that the compiler is telling us is like, oh, I can't actually find color. So what on earth do you refer to there? Now I thought it was inside image. But apparently life has changed since I wrote this code, which is not exactly what you want when you do a demo. I love. So actually, let's start with somewhere else and we'll come to it. So the first thing that we want to do is create a new project. We'll start from scratch. Actually, we'll get rid of all of this. And all I want to do here is create a command line file, a command line program that can print out its arguments. So it's a really strange place to start, I suppose, but we want to be able to make sure that we can take arguments from the command line and print them to the screen. Nope, we're getting a whole bunch of other stuff here. These two are the... oh, we'll just remove our imports because we're no longer needing them. Now we get some other things as well. We want a usage doc, so we need to bring this one back in scope. And we've got one that we are actually using, and we will probably need those other ones too, but we'll get there. So we're just going to get through these compile errors. Okay, so this is what we needed for... so our first argument is this arg1 thing. To print an object to the screen, we invoke the print line macro by providing these curly brackets and then an arg. So this feels a lot like Python's formatting, which is kind of what it's intended to feel like, I think. And now it's saying, whoa, I don't know what you mean here, sir. I need to provide a little bit of extra syntactic sugar, which actually under the hood asks Rust to use the debug output, not the display output. So this semicolon question mark syntax will opt in to providing output that's designed for a programmer to read rather than kind of the end user. Now we get into some really interesting other problems. I get told that we can't use it twice. What does that mean? Well, what it means is that we've encountered this problem with the borrow checker. Now, this is the famous borrow checker that like hits everyone up, like hits everyone in Rust. It is famously difficult to kind of understand. It's one of the concepts that's really, really complicated to get a handle of mentally to start with. But actually, once you've got it, it feels like, oh, I should have had this in every programming language. At least that's my view. So, what have we got? Well, what it's saying is that arg1 is being used up here. I've got this expect thing, and I'll explain what that is very shortly. And also arg2 is also being used. At the end of the call to this very first argument, sorry, the arg1.expect, we have a we've actually used up the value. By design, Rust won't allow you to use a potential, like create a situation in which there is illegal memory access. And so the arg1 has actually been kind of taken up in this input file name, and it's invalid. Even if you only need to read from that value, it's actually an invalid thing to do to ask for it later. So instead, one of the options that we could do actually is we'll see what our expect does before we actually see it in before we explain why it is that it is the case. So what we've got now is, so the lifetime of input file name is open. It exists for as long as we use it for, either to the end of the scope of the owner, which is this main function, or until we use it in a way that it provides until we kind of gift ownership to some other function. Now, printline actually doesn't require ownership to print something out. It takes a reference, and a reference is it's kind of the terminology in the Rust world is borrow. So that means that Rust will provide main with the ability to lend out access two other functions. In our case, we're invoking a macro, but the kind of the mechanics are the same. Now, if we try to, so let's actually run this. So if I've got this little helper utility called cargo, it comes kind of with Rust, and I'll just bring that back so that it doesn't kind of look really wobbly. Cargo run. Now we should receive this output, well, this usage diagram. Yeah, string. We blew up saying that it doesn't quite look exactly like we want. I'll just quieten that down. So we've got this thing thread main panicked at usage. What is going on here? Well, what's going on here is this expect call method invocation is trying to say that I expect that arg1 will be populated, and if it is not, print out an error message, which is the usage doc. Now, this is not like an ergonomic way to do it, but it's a very simple way to get yourself kind of off the ground. And like, if you're creating a command line utility for yourself and you don't really need like very, very pretty output, this can kind of be enough. And so we actually need to supply it with an argument on the command line. So I'll just say that cargo run is actually compiling our project and then copying it into or creating an output into this thing called fu. Now this is the executable that's actually being run. So if I give it an argument, and I just want to say text1, and then actually I'll just do hello.text and then hello.png. So that's where we're going to end up. We get our output, which is arg1 is hello text and arg2 is hello png. So that's the very, very first thing that we want to see. I'm going to need to, now Rust is actually updated. So as I was mentioning very, very early on, this is actually an Easter egg inside the source code examples. It doesn't exist in the book directly. It's used in some of the pictures that are generated in chapter 7, but it isn't actually provided complete. So if you've just joined the stream, I'll just provide a little bit of output. What we're trying to do is create these PNG files of file formats, and so you can see that HTML looks a little bit different to, oh, and I played around with some of the color variations. We can do that too if you want to play with me. Is that the right terminology to use? I don't know. Hey, welcome, by the way. It's awesome to have an audience. If you feel like it, just a quick reminder that you can always ask a question in the chat, and I will be very, very happy to answer. So we need to include a an external library. In Rust, an external library is called a crate. Now, you know, because that's kind of cute and fun. Sorry, I'm just kind of getting a bit lost. The reason why I've got this old syntax is that this example was written when before the 2018 change, and as it is like an Easter egg, I haven't updated. So let's see if that will. Oh, we need to build it. So I'll just click run again. Okay, it's saying unresolved, no image. Okay, so what on earth does that mean? Now, if I go to cargo run, I've got inside here I've got my dependencies. What is wrong with this? Could not compile arrayvec. Why not? Now, if we no unresolved, that's a strange error to encounter. But I want to show you what it is that I'm doing. So what I'm trying to demonstrate here is that Rust has a very, very rich set of like third-party libraries that you can call on. And the one that we're going to call on is this thing called image. Now, to to explain the story, we go to docs. Well, one option is to go to docs.rs, docs.rs, and then /create name, and there's the version number. So this is the most recent one. To find them though, we go to cargo.io, and then there's a and we've broken. Apparently the internet is dead. That's not a great thing to encounter. Now, did I go to the right website? I'm sure I went to the right website. Oh, it's crates.io. Of course, it's not cargo.io. Come on. Yeah. Right. So that's actually a very, very important. So I just had someone fix my code, which I'm very grateful for because I was super confused. Now I'm going to still ask for the 18 because I don't want it. Okay, right. Okay, so super helpful there. I just got myself a bit trapped, and thank you, I've been untrapped. So what I needed to do was tell Rust that I'm using new syntax. So previously I had this extern crate but I hadn't opted into the new behavior, and so to do so I needed to move to the new edition. So I've done that. Great. Now I'm going to and now I'm compiling, and now it's saying, buddy, you haven't actually used this anywhere. So what I want to do now is create a picture, and let's try this. I'm just going to ignore the arguments that I've created. Oh, maybe not. Maybe we'll actually create an actual file. We won't worry about reading it in. Oh, no. We'll go, sorry. I keep changing my mind about what I want, where I want to start. We'll use this. Let's create a picture. What we're going to do is invoke this new method. Now Rust doesn't have constructors. It only so this is just by convention. The Rust community has decided that the new method is how to create a new object. There's actually a different way. So if we ask for not found in scope, okay, so I want compile, I want height, Oh, I see. Okay, so I need this width thing again. So I want to say that I'm going to make it 512 pixels wide using an unsigned 32-bit integer. And likewise with height. I can't find that crate. Okay, so file. Oh, right. So I'm going to need to read in a file. Okay, we'll do so. So file in is the file input file name. And the file that I want to create is, it's got this ampersand thing on it. Now ampersand sort of tells Rust that I'm sending a reference to open. Do you remember at the start we hit this problem where I encountered this borrow checker error. Now we've got a weird situation, and I think we'll probably recreate it, that file is not found in the scope, so we need to bring in file. So do that. It's saying RGB image is not in scope, so I'll need to do that. I won't do a glob, like a glob import. I will bring it in explicitly. And now we have this kind of weird situation where, so we get this error that we haven't supplied the argument. So we're still not in this. So if I were to run with, I'll do cargo run --12, and it will work. And now we get a different error saying that I'm unable to open a file, and we kind of get this horrible output, but let's ignore that for now. So we're trying to create an image by reading a file. Here we're saying that we've got, but the problem, the confusing thing for a new programmer is that in println I'm not specifying an ampersand, but in open I am. Now how does that work? Well, it works by by chance. Not really. It works by some special behavior which says that, well, not even special behavior. It works because inside println we, oh, and I probably shouldn't have gone to the definition of the actual internals, but the internals eventually go to, well, actually, no. Actually, I'm not going to muck around with the inside of the stuff. What it ends up is actually internally it only needs a reference, and so yeah, we don't actually need to supply it as an argument. It kind of figures it out for itself. Whereas the expect method will take things by like in a more concrete way. It will kind of suck up the argument that I'm saying. Let's get to the point. Sorry. Okay, so now we're in the situation where we're able to pass in arguments from the command line. We need to open a file. So the first thing we should do is probably find a file to open. And I, for some reason, thought it'd be funny and interesting to create a to get some Much Ado About Nothing, you know, Romeo. So I downloaded Project Gutenberg's Much Ado About Nothing by William Shakespeare because I thought it was kind of this weird recursive thing that I'm creating a project about nothing, really. Does anyone else find that funny? Not really, probably not. So I'm going to use the cargo file that I've just created, and now it's saying that I don't have an output file, so I'm just going to do cargo.png. Now cargo.png is the second argument, but we're actually not going to do anything with it. Okay, so we're in a much better space now. So we're actually opening the file. We do that before we trigger the error that it's encountered. So let's prove that. So how do you read from a file? Well, I've got this file in thing, and I by default need to supply a buffer, but there's also this really useful method, read to string, and it's saying I need a mutable reference to a string. So let's say mutable, I need to create a mutable value, contents, string new, and contents. Now I can print the contents of contents, which is probably a good reason not to use that as a variable name. Now this only deals with the input file name. Oh, now it's saying that that's not valid syntax. That was just my editor deciding that it wanted to be helpful. And did I mean to use a semicolon? Yes, I did. Thank you, Rust, for being so helpful. That's very nice of you. Not a type. Expecting a type here because of method not found in standard S. Okay, so we're getting some really interesting error messages. What it's saying is that this read to string thing doesn't exist, but my editor thought that it did. So where does this come from? It's probably defined in some extension. It's definitely inside libstandard. Now, I bet it's in this IO prelude. So what is happening here? What on earth have I just triggered? Well, what I've just triggered is that the core type, this file thing, doesn't include the method, even though, so what's very, very customary whenever you're dealing with IO, which are files, network, and anything like that deals with input and output relating to hardware peripherals, is that Rust, sort of idiomatic Rust will include this kind of magic string, like use standard IO prelude glob and bring everything from that prelude into local scope. So we can kind of go and dig into what that prelude actually is, but it provides a bunch of helper methods, including, fingers crossed, sorry for tapping the mic, fingers crossed it includes the read to string. Oh, it does. Great. Okay, so now I get another error message. And this one's actually very, very helpful. It's saying, actually, look, mate, Tim, come on, Tim. You've given me the right type, but I don't have the right access. I don't need ownership over it. I need a mutable, a read-write reference. So there's, like, as we've touched on earlier, there's kind of a couple of different ways that you can pass access along with a value to a method or a function. By default, you will be providing, you know, that is just with the, if you just pass the variable in as is, we kind of provide ownership. So we gift our ownership of contents, so main currently has ownership, into read to string. Now that wouldn't be super sensible in this case, because after the read to string is finished, it would no longer be valid for main to access contents again. So the only special thing that an owner can do in Rust is it kills, like it cleans up once at the end of its scope, and so there'd be no point in sending contents into read to string, because you'd no longer be able to read from that string afterwards, because it would have been deleted at the end of the function. We can provide a read-only reference, but this is called a borrow. Now read isn't super useful because the whole point of this method is to actually mutate or change it and take the content from the file and put it into a string. So let's see if we can get a little bit closer. Hey, we can. We get a whole bunch of warnings, and I can explain those too. But right now, if I just run the cargo with the quiet option, it will actually still pretty, and it's pretty angry with me. It really doesn't want me to do some of these things. It's saying, we're not using all these variables, you really shouldn't be bothering with them, what on earth. And let's try, okay. Okay, right, so here's a problem. Files can break. Between calling the operating system could trigger an error at any point saying, you know, the file has been deleted, or maybe it's illegal to access it, you don't have the right file permissions, for example, and so this read to string thing may fail. Now how do I deal with that? We chain methods. So the easiest one is actually unwrap. I say easiest, but also it's very heavily frowned upon. So what on earth is this? What the idea is that we, touching the mic, probably not a great place for a microphone, possibly. I think every video about Rust explains in detail how the borrow checker works. Well, yeah, maybe. I think one of the reasons why that is the case is that it's such a novel concept. It doesn't exist in other programming languages. It also seems to be the area where new programmers to Rust tend to get trapped. And the other thing is it's really, really good and very, very useful as a way for kind of ensuring that you're programming in a way that is robust. And so it's actually very, very nice as a programmer. You know, whenever I go back to Python, or whenever or another programming language like say Go or Java even, although I do less Java, I always wonder about when a value will be deleted. And I'm get really scared of accessing things at the when they shouldn't be accessed, and so but I think it maybe it's interesting actually. Maybe it does get over explained. Okay, read to string. We've got contents. We can now print them to the screen. We now we extract the metadata from the file, and one of the things that we want to so what we needed to do was deal with this error message. Now the unwrap method is kind of the least pleasant way to deal with it. I say that it works fine, like it works perfect here. Now the problem is and let's see what the we get this kind of, it will panic, and then panic means crash, and it will panic in a way that is really unfriendly. We will just get this warning saying that we could not, like our file panicked at this line, and that is all the user gets. So if you are developing something for yourself, maybe unwrap is okay, or if you can kind of guarantee that it won't blow up on your face, then like in this case, for example, if I was to read from something that I had created and it wasn't an actual file living on the file system, if it was an in-memory file, like it was a test, for example, then I could potentially use unwrapped. But a slightly more ergonomic way, or a slightly friendlier way, is to use this expect function, which is this, like file access blocked. File access, it's really hard to know what to write in these kind of situations, but file access, if I just write illegal file access, it's actually not very helpful to the user either. File permissions? So the reason why we know that we know that the file exists. The problem is that we couldn't read it, so that we can exclude a few errors. There are actually ways to dig into the error the error struct. We can actually go in and dig in what the operating system is actually providing for us, but I kind of want to avoid that right now. So this is one of our options. Another, yeah, I'm actually just going to leave it there. And now we get, because I want to start printing some pretty pictures, and people have been waiting. We've got like dozens of people in the, like just eagerly checking in, saying when are we getting these photos? So just to remind people what we're actually kind of doing here, we're going to be able to create a little utility which enables us to look inside a file format and see the differences between, this is a Mobi. So this is I believe a file format from Adobe. No, the Mobi, so there's an e-reader thing. Amazon's Kindle, I believe, reads this, and now it's an encrypted file format. So we can't actually see inside, but we can see that they have these kind of dark, like it feels like there's like these partitions within inside it. And those partitions don't exist within other formats. So here's an HTML file, and we see lots and lots of white and a little bit of gray. And whereas an EPUB, it is much more compact than Mobi, but it's sort of scrambled, and that's because it's a compressed file format. In fact, it's just a zip file. Zip files are also encrypted inside, or at least compressed. With a password, they're encrypted, but yeah. So so let's get to the files. So we're reading in. We can now print the contents of a file that we've selected, so that's useful. And now we want to read in metadata. Now metadata is useful because it tells us how long the file is, and the file length is important because we're creating images and we need to know how big to make them. A really useful extension of this project is actually to do something really neat. which is to, and this is for any math geeks or any, oh, what's the default message on Unwrapped? There's some questions coming. What is it? It just says panic. So let me invoke the we'll invoke that problem. So the question was, you know, what does expect do by default? Shouldn't it provide something useful? Well, no, it doesn't provide anything really useful because it's a generic facility for every single time that Rust blows up for an unknown reason. So whenever you encounter a result or a struct, now all we get is this thing saying thread main panicked at none value. So like, what? What it's saying is that in this case we're unwrapping an option and trying to get in what it is there rather than a result, but kind of the result is the same. That there was nothing here for this args env number 2, so we're asking for the second command line argument, and there's actually, it doesn't exist. And unwrap just panics with this thing that if you want, you can run it with Rust backtrace equals 1. So we could do that and see Rust backtrace equals 1, and well, maybe that helps. Oh, we will need to actually invoke the error. Blah. That's not very helpful to a user either. So no, the reason it can't provide anything sensible is that it is, well, there's two reasons actually. One is probably that it's trying to be intentionally minimalist. It's only doing what it's being asked to do, which is unwrapping the value. If you are so an enum in Rust can actually contain data, and the unwrap method is taking the error, or sorry, the result that comes. Let me explain. So if you ever encounter a result in Rust, what you're actually getting, well, I can't even spell, is OK and then T. We'll explain. T is any type. This isn't valid Rust, but you also get this error, and this actually has an E thing. So because they're two distinct types. So an unwrap will actually try to pull out T. That's all it's doing. And the panic is actually occurring because there's no T to unwrap. In the case of the args thing, it's option. It's saying that I can't unwrap. I can't unwrap none. There's nothing to unwrap because it's just defined as just by itself. Now, that's all unwrap is doing, and so it's not actually there as a facility for error checking. It's just there for the programmer, and yeah, it's not a very user-friendly tool to use. Now, there was another question: shouldn't it print something useful? Oh no, so I've answered both. Great. Okay. Now, where am I? I've got a height, so we now know. Oh, so the really cool thing you can do is you can plot these on a Hamiltonian curve, and then you can get things inside the unit circle and make that arbitrarily large for any value. But I didn't want to go and explain Hilbert curves. Sorry, Hamiltonian. We can plot on a Hilbert curve, and then we can kind of create a fractal of infinite depth on a unit square, because it's a space filling curve, or any space filling curve in fact. But that was kind of beyond the scope of this particular book. I mean, this particular chapter. Now, we're getting some interesting differences between what I'm doing and what the code does. So I need to do the exact same thing in a different way. So I'm just going to reuse our file method, and that is I'm actually going to read it in as a different type. Instead of a string, I'm going to create this vector of U8. A U8 is an unsigned 8-bit integer, which is useful. It's just a byte, so we could we can't. It's not a legal type. I mean, we create a type alias, but we're just saying it's just a vector of raw bytes. Now a string, we can't use a string for this because strings are guaranteed to be UTF-8 encoded. Now we don't want that in our file. So what we can, and so instead of saying read to string with a brand new string, we are asking read to end with bytes. Hopefully that makes sense. That now bytes is basically the same thing, except for the fact that we don't have any guarantee under the hood that it's actually representing text. So to create our image, we can go through every pixel and then set its color. Now I encountered a very weird problem right at the start, which was that this color thing doesn't exist. So I've got some code from some old thing. Now I'm going to show how to kind of remedy this. So let's say I've got this notional color and I want to create an RGB. So I've got an RGB struct and an RGB image, so they kind of align. And what happens, actually, I'm going to make this a little bit friendlier to people who haven't used Rust before. So what I'm going to try and do is I am going to ignore this color thing. It's getting a spelling error because I've actually got it set to UK setting. So let's ignore what color is and let's just concentrate on enumerate pixels mutably. So we get an XY and then the pixel color. So all the pixel data. Now we know that it's an RGB image. So we've got a red field, a green field, and a blue field. Now we need to index into bytes. This will always work because we've set our image to be exactly the same height as what we've got in the length. I'm wondering now maybe that's not the case, because potentially there are rows that, sorry, just kind of thinking out loud. We could have done it the other way around. So I can also go through bytes for byte. So this would be in bytes. We can iterate through, and then if I call enumerate, actually I probably could do it this way because I only need to read the values. So by design, if we iterate through a reference to the vector, we get a reference and it grows, and then it iterates through a reference to every value in the inside it. Maybe I'll leave it there, and then I'll just print. I'll just show. I'll just show exactly what's happening. So we can start by. I'm going to add a some more special syntax, which asks for a hex value. So if now I want to also width. So what I'm going to do is create a. Now let's actually have a look. What we want is a whole bunch of hex values to be printed, and I might add a space. And then there'll be 512 wide, so I'm just going to change this just very, very briefly to, say, 10. And we've got a whole bunch of problems. Consider removing the leading ampersand. Okay, I'll do so. We'll go through the bytes array inside the file and then print out its raw value as a byte, and then so we're not actually creating cargo.png yet. Oh, it's a whole bunch of stuff saying that we've got type errors. Now that's not super helpful, so I'll just cast this. To cast numeric type, I can, or primitive types, I can use it as functionality. Now Rust has quite particular rules around casting. What is usize? That is, like, what do I mean by particular rules? Well, it will only operate, it requires everything to be explicit. So even though it could coerce a U32 with a usize, because it could probably oh, that's also, I want to say it could do this coercion itself, because it would be pretty easy to cast U32 as usize automatically. It will not do so, because it's trying to tell you that you are you're responsible for your own code. Now I'm actually just gonna get rid of this stuff, doing a lot of like coding by commenting. Ah, look, okay, great, okay, cool, that's really fun. So we've created our little table of hex values. Now interestingly, it's not quite aligned because the A isn't, let's see if I can add 2 in there, because the format string takes some arguments which allow me to put in a default, and so I'm going to say that if you can't, if the byte can be represented in a single character, so in the A byte can be, just pad it out with a 0 and up to a maximum of 2 bytes padding. That makes sense, because a hex value. So if we want, for whatever reason, because we're feeling very special, we can pad it out with more. Right. The way that I decided to do it when I wrote this is kind of, instead of going through the byte array and going back in and changing the image, I went through all the pixels and then changed them. Now, so we can, let's try and see if we, to explain it, so to convert between an XY space and I am just taking the X coordinate, which is its position in the row, and adding that to the number of rows. So we get and that kind of gets me to a numeric, sorry, absolute. Okay, it converts between 2D space and a 1D space, because byte's only a 1D. Now we need to just set, we can try something really maybe a bit weird, which is, we'll start off by just explaining what this star pixel thing is. If you've never used pointers before, or never used the systems programming language, this can be one of the most, like, I found it a really intimidating piece of syntax to get a handle of. And let me explain what's happening. So RGB is it kind of represents a color, I think. Makes sense. And we get this literal syntax, which is the instead of using new, we can use these curly braces and then add in values for the fields. Oh, what is the best Rust IDE in your opinion? This is another one of those questions where I feel like, sorry if it's been waiting there for a while. It's been so focused. I'm going to answer the IDE question once we've created a picture, and so we're just gonna. What happens here? Oh, nothing. I'm surprised that, oh, okay. First thing we need to do, we're introducing a new variable, so we need to use let. Now, what happened now? Nothing. Because we didn't save it. I don't know if this is useful or funny to anyone, but we actually now need to actually output the value. So we created a wonderful image. It was, you know, masterwork, masterpiece. But this will just create a grayscale version of the output file name. Oh, so we also hid that one. Where are you? You're over here. Okay, and now we don't get any output, but... oh, why are you not happy? You could view other PNG files, but not this one. I wonder... oh, there it is. It's tiny, because it's such a tiny, tiny little photo. I mean, tiny file. So that is, you know, there's our masterwork. There's our masterpiece. Let's try running it on the same thing again. PNG can just run it itself. This is kind of recursive. It looks a lot different. What's happening here is the PNG file format. Oh, well, let's kind of give ourselves a clap. We got there. Now we've got photos. So I want to explain what the best IDE is. Are you gonna hate me for saying it depends? I would say so I am using Visual Studio Code with the Rust Analyzer extension. Now, I personally prefer bigger things, like Sea Lion works really, really well with Rust, and also, actually, I would give Emacs a turn as well if you have used Emacs before. Now, the problem with questions like this is that it's so personal that I wouldn't take the recommendation of someone who is like talking to you over the internet. I would go and explore your tools and find out what works for you. There's a question like, well, why are you using VS Code with this plugin if you don't like it? Well, you know, it's not like I dislike it. It doesn't have. I guess the real answer is that, you know, it's free and open source, and so those are values that I appreciate, and that's why I use this one. And for small things like this, I get some advantages, like I can render PNGs. Because it's just an Electron, a web browser, it can handle this kind of stuff by itself. And that's handy in demos. Now, what else have we got? Let's so I just wanted to explain the star syntax, because if you've never used pointers, it's really intimidating. What star does is takes an address. So this is actually a well, it's not purely a memory address, and it's a reference, but and it basically says, go to that place and give me back what is actually stored at that reference point, and set it to whatever is on the other side of the assignment block. Now, over here, I see some kind of really interesting use of, well, I say interesting, I find it interesting. One of the cool things that I really enjoy about Rust is that all of its control flow, including for loops, actually return values themselves. And we can use this to our advantage. Oh, it's saying that it's overlapping, which is actually really, really helpful. So thanks, Rust, for helping me out and not allowing me to create a program that won't work. it's saying that this is not a valid value. So I've got 9 to 13, and I just move this one up to 14, I suppose. And if it's unintentional, prefix it with a byte. Oh, right, so now I no longer need this here as well. And the picture should change. So now I've got colored output. Now, this is not an attractive image, so feel free to create your own palette. What I was trying to do was trying to create something that was highly distinctive, let's say. And let's explain, just before we go, we'll wrap up really soon. So thanks very much for your patience. And explain what on earth it is that I'm trying to demonstrate. We said that null bytes, the zeros and zeros, are black. So that occurs up in the top, and white space occurs at the front. Now, I've designated integers, punctuation. And so what I wanted to demonstrate, white space is white and black is black, and these illegal values are in different colors as well, and you can play with them. Oh, by the way, one other thing for we've seen a lot of times in this demonstration where the Rust compiler has been really helpful to us as programmers. It's been exceptionally helpful. It's like a better programmer than I am. And so what else should we finally say? I would encourage you very heavily to oh, I'm interested in this question. Sorry, I'll do my kind of wrap up question very soon. I would highly encourage you to look into Rust if you haven't already. There are lots of free resources. There's also my book. If you're keen, I can send people I've got I have a code if you would like, and I believe Manning has published it as well. I am more than happy to answer any questions that you encounter online. I am online. Probably easiest is Twitter, but there are other channels as well, whether that is Reddit or like even the Rust forum on users.rustlang.org. And I am I'm really excited to be part of your journey if that's where you want to if that's where you want to head with your programming career. Okay, so we've got another question. I'm just going to change one little thing. I'm going to change it back to me. Get rid of the code. Okay, so I'm just going to hang out in the chat for a little bit and answer any questions. So I'm back over in the chat. I'm not super good at typing and texting at the same time, and I'll find that code for you. So we've got random Twitch question that actually worked. Hi Tim, was planning to start chewing this meat the weekend as the book seems finished. Ah, yeah, right, okay, I think I know what you mean. It's like, it looks like you're done. It's only been 4 years. First of all, I am so sorry that it's taken so long. At least it's very good. The book is basically done now. There are still bits and pieces to tidy up. There's still the odd typo. There are a couple of bits and pieces, including little things that say note to self, fix me in the text. But by and large, yeah, it's ready to go. There have been some production issues this year with COVID and so forth, but yeah, I would absolutely encourage you to take a look. Yeah. It's basically done. Basically, it's 100% complete for 95% of versions are complete. Are there any further questions? I'm more than happy to wait. Well, it's been a delightful stream, everybody. I really enjoyed. Oh, is the standard library ABI stable? Oh, that's a fantastic question. So first, for the advantage of people who okay, so for the advantage of people who don't know what an ABI is, it's similar but different to an API. But this is the way that Rust talks to other programming languages. No, excuse me. It wants to be ABI stable because then you know that today's Rust can talk to a C program or a Fortran program or like a JNI, the Java native interface, for example, like in perpetuity, which is as long as the computer is still running, the code will still go. Even with future versions of things. I'm flipping a little bit. The ABI is C's ABI. So Rust looks a lot like C++ to a disassembler and provides almost no, it doesn't do anything clever. Now I don't believe that it makes a guarantee that it is ABI stable. So I'm gonna double check that. I think that it's a very important question that I don't know enough of. My understanding is that it's not stable, or at least it hasn't been stabilized formally. And here is actually a thread inside the Rust. I'm just kind of looking as I was talking. Here's a thread inside the internals mailing list, not really mailing list, forum, where they're discussing producing a stable modular ABI. Now, so that implies that currently it's not. I just want to thank a couple of people, including Eulen Spiegel. That's for sort of unblocking me earlier. That was really, really useful. And for everyone that's asked questions, it's actually really fun. It's much more engaging as a presenter when you can help people out directly. I hope you've enjoyed the stream. I am about to sign out. And feel free to engage through whichever channel you feel suits you best. Manning is responsive as well, and so yeah, send them a note and see if you liked it. If you didn't, if you liked it, I'll see you all later. Hopefully I'll see you back on the stream. Okay, ciao.